Hi, I'm Paul. We're going to do an AP Computer Science Principles practice test courtesy of Barron's. And I can't think of any more of an intro. Let's get started. Okay, well, you will have 2 hours to complete 70 questions. All right. Next. How is this going to come up here? Yeah, I don't like that. All right, hang on. All right, so this should work. Get everything in the screen. All right, so the diagram below shows a circuit composed of logic gates. Each gate takes 2 inputs and produces a single output. And what will the above circuit output? All right, can we get it so we can see the whole thing here? Yes. All right. So at the top, we've got true and true coming into an AND gate. All right, I need a pen here. Now that AND gate with 2 trues coming in is going to return true. So we have true and false going into an OR. True or false is true, but there's a not attached to it, so we have to reverse it. So this is going to be false. Now we have false and true coming into an AND gate. That is going to be false. We have false and true coming into an OR gate. That is going to be true. But because there's a not attached to it, it's going to be false. And then we have false and false coming into an AND gate, and that is going to be false. So the answer to this is false. Let's look at the options. Okay, false. Whoa, wait a second. Isn't there any way to see whether the answer was right? Oh, here we go. Show answer. That's right. Okay. A spinner is divided into 2 sections. 3/4 of the spinner will return false. 1/4 of the spinner will return true, as shown below. Select 2 answers. It's not a very clear question, but I guess the question is which of these would return true 1/4 of the time. So the first one here, random 5 to 8, is going to return a random number between 5 and 8 inclusive. 5, 6, 7, 8. That's 4 numbers, and 1 out of the 4 numbers, yeah. So it'll when 1 of the 4 numbers is returned, then it's true. Didn't explain that very well. When 6 is returned, that will return true, which will happen on average 1 time out of 4. 5 out of 9 is 6, so that's obviously wrong. 1 to 4 is less than or equal to 2. No. That is, we got 4 numbers, but 2 of them will return true, so that's no good. Random 1 to 8, less than or equal to 2. That's okay. We've got 8 numbers, and 2 of them will return true. So 2 out of 8 is the same as 1 out of 4. Let's go with that. What is the value displayed after the following algorithm is run? All right. Let's see. So we'll set x to 0 and repeat until x is greater than or equal to 4. X is x plus 2, so it'll be 2. We'll go through once, it's 2. We'll go through a second time, it's 4. And at that point, it's greater than or equal to 4, and it's going to stop. So it is not going to get any greater than 4. The values displayed after the following program is run. You can probably do this in your head. I don't encourage that, but, you know, probably could. So let's see. We've got A is 3, C is 2, B is A, which is 3, B is B plus A, which is 6, and C is C minus B, which is -4. All right, first thing we print is C. I should have handled this a little bit better, but we're gonna print. Well, yeah, -4 and 6. I can't scroll and write, but it should be -4, 6 from what we can see there. And the only thing that starts with -4 and 6 is D. As I recall, B is 6, A is 3, so that's going to be a 9, and that is the answer. How many passes using a binary search are needed to find the number 11? All right, how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so the middle number would be at, okay. Well, let's just use a 1 base to indexes here and say that the middle number would be this number right here, the 6th number, 901. And so that means that, well, it's too high. So we can throw out everything up here. Now, we're going to do it again. We got 5 numbers. What's the middle number? 11. Oh, okay. That's the number that we're looking for, actually. So the correct answer is 2. We're going to take two passes. Whoa. Oh, I didn't check the answer, did I? Okay. How many passes using a linear search? I'm not thrilled with this question because of this passes. What does passes mean? If we said, I mean, because usually we consider one complete iteration through an array to be a pass. We call it pass, but so is the answer 1 or is the answer 3? If we changed passes to say how many comparisons is it can take, I think it would be a better question. But I think, you know, saying 1 is just too trivial. So what I'm going to do is say 3. Okay. What does the following program display? So what we have here is a program that looks like it's supposed to do one thing, but in fact it does something else. It looks like it's going to take input from the user. It's going to set found to false, and then it's going to loop through every item in the scores list. If the item entered by the user is equal to, you know, each element in turn, then we'll set found to true. The problem is that if it doesn't match, we're going to set found to false. That's really not what we want to do, because the only way that, and then a little typo here, but the only way that found is going to be true when it gets down to the display here is if the user input matches the last item. Because this is always setting found every time. If it's a match, it's set to true. If it's not a match, it's set to false. I mean, what we would really want to do is if item equals X, found is equal to true, and then break out of the loop. But it's going to well, I can see the answer here. This A is not right because of the way the if statement is handled, but it will be true if the input value is the last element in the data structure. Yeah. Okay. What will the following program display? All right. Well, let's keep track of the variables. So we have a list. We have display, and then a call to the mystery procedure, and we're going to pass in that list. So it starts out like this: max is list 1, and in APCSP 1 is the first item in the list. Unlike some programming languages that you may use, even in APCSP, you may use Python or something, but in the pseudocode that's used for APCSP, 1 is the first element of the list. So here's what we have. Max is 11. Index, which I'm going to call I, index is 1. Count is 1. All right. For each item in the list, if item, all right, so item, we're going to go through the list. If item, that would be 11 to begin with. If item is greater than max, which it is not, then do something, which we don't have to do, and add 1 to count. Okay. Next time through, this will be item. Is item greater than max? Yes. Max equals item. Max equals item. Index equals count. Count equals count plus 1. Okay, and then the last item we'll go through, is item greater than max? No. So we don't have to do any of that, but we do increment count again. Count equals count plus 1, so count is 4, and we return index. Okay, yeah, so we return index, and we're going to display the return value of that procedure. So the answer is going to be 2. Let's take a look here. All right, let's go with 2. Okay. Pick 2 of the following that are the result of implementing metadata. I usually think of metadata as being data about data. It's not the data, but it's data about data. So, a streaming movie service suggesting movies to view based on your previous movie choices. Yes, because there's got to be something in there, some kind of data to indicate to the streaming service what movies are like other movies. So that is metadata. So that will work. Adding a rainbow in the sky? No. My dog's swimming? No. Average minutes spent on social media? Yes. That is metadata. So let's go with that. Okay. What is the following answer to the binary addition problem? Okay, Well, let's start out with this. Binary has 2 digits, 0 and 1, not 6 and 4. 4, no. So if we add these, I mean, you add up the low end digit. So actually it would add like this: 1, 1, 0. Oh, that's terrible. Hang on. Wrote it too big. So you would line it up like this: 1, 1, 0, 0, and add it. And 1, 2, 3, 4, 5, 6, 7. Well, I mean, this is too easy. This is too short. I mean, it's only 6 digits, and we have a 7-digit number here. You add these, the low end digits, 0 plus 0 is 0, so it has to end in 0. So the only possible answer here is D. Which of the following will result in a true value? Let's see. True and false. True and false. That's false. Oops, lost the pen. That's false. But not false is true. So we have true and true. So 1 is true. True and true. That's true. But then there's a not. So that changes it to false. We're going to have false and true. That's not true. Not true and true. So true and true is true, but we put a not in front of it and it becomes false. If we say false or true, that's true. So the answer is 1 and 3. Table below shows the possible values for input A and B. Let's move this up so we can see all the answers. Which of the following expressions shows how the output could have been outputted from A and B? All right. One possibility, A and B. That's not going to work because the first one doesn't work with that. True and true equals false. So that's wrong. A and not B. True and false. Well, that would work. True and true equals false. No, that doesn't work. And then therefore, because this is really the same as this, except, you know, we're switching the variables, this would not work with this. So we'll say not A and B. True and true. Is that false? No. But not A and not B. Well, we'd have false and false is false. False and true is false. True and false is false. True and true is true. So the answer is D. Okay. Which of the following can be represented by a group of bits? Oh, man. Well, I mean, it's computers. Everything is represented by a group of bits. A high-definition picture? Yes. A number? Yes. Program code? Yes. All of the above? Yes. Which of the following is not an example of metadata? The time a website was accessed. That is metadata. A picture of a waterfall. I don't think so. Geolocation of a waterfall. Yes. That's so, you know, you can upload, you know, that can be encoded in your photo, and then you upload it, and the photo knows where it was taken. The amount of times a user accessed a website. So really the only thing that's not would be B. How many numbers can be stored using 5 bits? Well, if you want to know how many numbers can be stored using n bits, it's just 2 to the n. So in that case, it's 2 to the 5th. Each bit has 2 possible values, so it's 2 times 2 times 2 times 2 times 2, 2 to the 5th is, whoa, wait, I gotta show the answer. Where's show answer? Did I go too far there? What happened? 2 to the 5th. Oh no, now I'm lost. Okay, here we go. The procedure alarm clock. Procedure alarm clock below uses a string parameter called day and returns a string that indicates a time. Which of the following will return 6 o'clock? Okay, well, the only time it's not going to return 6 o'clock is if the input is Saturday or Sunday. Because if it's not Saturday or Sunday, it's going to drop into the else and it's going to return 6 o'clock. So Monday, yes. Tuesday, yes. A misspelling of Saturday, yes. So that's 1, 3, and 4. And that is C. Following question uses a robot in a grid of squares. The robot is represented by an arrow in the lower left square of the grid facing right. Which of the following code segments will move the robot to the shaded square? The simplest thing would be to just move forward 4 times. Is that in here somewhere? See, if you start out with a rotate, you're going to make your life more difficult. Especially if you rotate right, because now you're like pointing out the end, out the bottom of the grid. This is what we want here. Just move forward 4 times. So let's go with that. All right. What is the value displayed after the following algorithm is run? Right, x is initialized to 1. Then we have a loop. Repeat 4 times, and each time through the loop we add 2. So what's 4 times 2? 8. So we'll wind up adding 8 to 1, and we're going to get 9. Which of the following contribute to the digital divide? Yeah, there's always a digital divide question on the AP CSP test. Sometimes more than one. So cost of technology, yes. Access for the disabled, yes. Lack of education, yes. Lower performance computers, yes. So really all of them. 1, 2, 3, 4, show answer. And that is correct. I don't know. Let me see the explanation for that. Differing access to computing and the internet based on socioeconomic or geographic characteristics, such as cost. Well, okay. I mean, computers can be expensive, or, you know, if you spend less, you'll get a lower performance computer, and you won't be able to do maybe all the things that you want to do access. Oh, it was disability. Yeah. And education. All factors contributing to digital divide. Okay. Which of the following describes symmetric encryption? Encryption is a complex topic. The questions that you get on APCSP probably will not be, will not be complex questions. So in that case, symmetric encryption just means that you use the same key to encrypt and decrypt information. That is not always the case. Sometimes you have one key for encryption and you have another key for decryption, but symmetric encryption is what the name suggests, which is a single key is used to encrypt and decrypt. Which of the following will not give an overflow error using 4 bits? How many numbers can we represent using 4 bits? So we went over this before. The answer is 2 to the 4th. 16 numbers, but that doesn't mean you can represent 16 because you got to include 0. So we can represent 0 to 15. So 16 will overflow, 32 will overflow, but 0 and 15 will not overflow. So it's 2 and 4. Sequencing, selection, and iteration are building blocks of algorithms. Which of the following is considered iteration? Counting the amount of even numbers in a data structure filled with numbers. I'd say yes. I mean, that's the kind of answer that is probably worth looking at, looking at the rest of the answers. But it sounds, it's not the counting so much as it is, making a pass through the data structure. But okay, yeah. So you would iterate through the data structure and count the even numbers. So that's promising. Using a Boolean condition is not iteration. Just determining if a number is even or odd, that's just a computation, not iteration. Finding the absolute value, not iteration. So we are going to go with A. All right. How many times is the program statement executed? Okay. It's just X times Y times Z. I'm going to do the show explanation and see if they have a better explanation. But yeah, nested loops. You want to know how many times it's going to be executed? Just multiply the number of times that each loop is executed, the loop at each level. So in this case, X times Y times Z. C. Okay. Go ahead and explain that. Okay. Just need to multiply the repeat numbers. Okay. Which of the expressions is equivalent to the Boolean expression num is greater than or equal to 13? Well, it's right here. It's greater than or equal to 13. So that means it's greater than 13 or it's equal to 13. And this is one where, you don't really need to look at the rest of the answers. Okay. An algorithm has a number of steps. Which of the following would not be considered a reasonable number of steps. Okay, well, a polynomial algorithm, I hope I'm not overgeneralizing here, but a polynomial algorithm is going to be a reasonable number of steps, okay? N cubed, yeah, we have algorithms that we use, you know, that are in common use that are N cubed. It's not ideal, but it's reasonable. This, we're going to go up to N squared. This, we're going to go up to N squared. If you have, like, some integer to the nth power, now you've got an exponential algorithm, and the number of steps involved in that is just going to skyrocket, and it's just it's unusable, except with very small values of n. So this is not a reasonable number of steps, an exponential algorithm. All right. Which of the following are not possible using random and display? Okay. Can we get 6? Yes, we can get 6. Wait, can we get 6? No, we can't get 6. Because the smallest number we can get here is 3, and the smallest number we can get here is 4. So actually the numbers that we can get are between 7 and 11. So what does it say? Which are not possible? So we can't get anything that's not between 7 and 11. Which math solution below could result in a round-off error? Well, okay. 2 plus 6, no. These other ones here, I mean, I'd hate to speculate what you're going to get. You probably an overflow error on that. This is okay. It's just a power of 2. So, you know, you're going to you're going to shift it to the, let's see, which direction would you shift it? You'll shift it to the right and then do a multiplication. It's not a round-off error. I mean, actually, the round-off error is this. You're going to get an endlessly repeating decimal, and you can't represent those exactly in binary. So you can get some weird results when trying to represent decimal numbers in binary. So let's go with A. When a new model of airplane is introduced, the airplane manufacturer trains pilots using moving simulators. Why? A simulator allows for pilots to be trained on a new feature without endangering passengers. That makes a lot of sense. A simulator can account for all variables. Well, okay. On AP tests, or, you know, ACT tests or SAT tests, or, you know, whatever. Anytime you see something like always, never, all, none, you got to be very careful about that. Those answers are almost never right. So a simulator can account for all variables. No. Simulator is not cost effective. No, I would think it would be very cost effective. All of the above, no. It's just like, you know, we don't want to we don't want to load the plane up with, you know, real passengers and then take off to test some new feature. So let's go A. A large data set shows information on students about to take the SAT test, GPA, intended major, college that the student is interested in, high school name and location. Which of the following could not be answered by analyzing only information in the student data set? Number of students accepted to a college. I don't see that in there anywhere. How many students are interested in a college? Yes, we have that. I can't highlight it there, but yes, we have that. How many students from a high school are interested in a college major? We have the high school and the intended major. The GPA, we have the GPA, but we do not have information on students' acceptance. So let's go with that. What's the value displayed after the program is run? Okay, so we can't do this so that we can see the program and the answers at the same time, but okay, just go through it then. So we start out like this. A is 8. B is A mod 3. So mod is a remainder. 3 goes into 8 twice with 2 left over. And that's the mod. So B is 2. C is equal to B. Okay? C is equal to B. A is B times A. Okay? So that's 16. C is equal to C plus 4. Display A and display C. All right. So be a little careful about this because this, you see the A is in quotes. So it doesn't, that doesn't mean display 16, display the value of the variable A. That actually means display the letter A. So we should get the letter A, and then C is 6. So it's A and 6, which is right here. What is displayed after the algorithm is run? All right, so X is initialized to 4, and then we'll go through this loop 3 times. If X mod 2 equals 0, so first time through it's 4. 4 mod 2 does equal 0, so display lily goose. And add 6. So it doesn't matter how many times we add 6. X mod 2 is always going to equal 0. We'll get 4, 10, 16, 22. It'll be an even number. Mod by 2 equals 0. So it's just going to display the same thing all 3 times right here. What is the value displayed after the algorithm is run? Let's see all the answers here. All right, so X is initialized to 0. And we've got a nested loop here that adds 1 to X. How many times does it do that? Well, we went through this earlier. It's like just multiply the number of repeats. 4 times 2 is 8. And so we'll add 8 to 0 and get 8. What does the following algorithm return? All right. So A is true, B is not false, which is true, C is true, everything is true. A, B, and C are true, and D is an empty string. We don't really have to write all this down because the values are assigned, but they never change. So we can just remember that they're all true. So first, if A is true and B is true, which is true, D equals D plus cherrywood. Plus is fine for concatenating strings together. It doesn't just work with numbers. So D is going to be cherrywood after that first if statement. If A is true or C is true, which is true, we are going to add apple. Okay, so now we have cherry, wood, apple. If A is true and C is false, C is not false, so we don't have to worry about that. So we have cherry, wood, apple. And that is right here. User inputs 3 for the value of A. That is right here. What is not a possible value for C? All right, so B is going to be a random number between 3 and 10. And C is going to be 10 minus some number between 3 and 10 inclusive. So 10 minus 3 is 7. 10 minus 10 is 0. So so the only thing that doesn't work is a number that is not between 7 and 0. The only number that is not between 7 and 0 is 9. Following question uses a robot in a grid of squares. The robot is represented by an arrow in the lower left square of the grid facing right. What are the possible landing spots for the robot after the following algorithm is run? All right, I would like to be able to get, okay, so I don't need to see line 10. Can I see it? Yeah, just about. All right, well, so let's try it. Y is a random number between 0 and 1. So that means we're either going to do this once or we're not going to do it at all. So let's start out first time and say we don't do it at all. All right, next, Z is going to be a random number, 2 or 3. Repeat n times, move forward. So that would be 1, 2, right here, or 3, which is right here. All right, the other possibility is that this random number Y comes out as 1, and so we rotate left. Rotate left means that arrow would point up. And again, we would move forward 2 times or 3 times. 1, 2 is right here. 3 is right here. So that is what we're looking for in terms of an answer. I'm going to commit that to memory because it's going to disappear when I start scrolling. A is wrong. B is what we got, actually. So let's go with that. Yes. What is the benefit of a high-level programming language? A high-level language makes the algorithm easier to read and edit. Yes, it does. High-level language is faster than a low-level language. No, no, it's not. More computers can interrupt a high-level language. What if they meant to say interpret? Well, it's wrong in either case. A high-level language can be used directly by a computer, thus using fewer steps. No, that's wrong. It's backwards. High-level language has to be compiled into a low-level language. So we are back with A. Which of the following could be scaled to use? Citizen science. I'm sure you'll have at least one question on citizen science. A, understanding of habitat characteristics and invasive species in the Great Lakes near shore. Okay. Yeah, possibly you could get citizens to go out and observe that. It makes some assumptions about, I don't know, maybe people's understanding of species of Great Lakes nearshore animals, habitats, and so on. But I suppose you could, yeah, I suppose that's possible. B, clinical trials of the effect of a drug on humans. No, no. We're not going to be doing, drug trials on random citizens. Collecting air quality data in communities using sensors. Well, no. I mean, yes and no. you could get citizens to go out there and place the sensors and read them, but I think the fact that it says using sensors means you could do it without the citizen science. And D, oral histories from expert fishermen, yeah, that's more like sociology, isn't it? So I'm not wild about answer A, but of the answers that we have, I mean, D is definitely wrong. B is definitely wrong. C is, it almost sounds right, but I think the fact that the work is being done with sensors, it makes it wrong. So we will go with A. Still a little puzzled by that. I mean, I could go to the Great Lakes and really have no idea what I'm looking at there. But I don't know. I mean, I could take photos, I guess. Well, let's go with A. All right. Which of the following is an example of targeted advertising being misused at an aggregate level? A, discrimination in advertising for housing, employment, or credit. That's the kind of question that the AP-CSP test writers like, is discrimination questions. Okay, so that's probably the right answer. Sending targeted advertisements based on the user's cookies. Well, I mean, that's not a misuse. That's kind of what the cookies are for. And like every website that you go to now, you know, you agree to the cookie policy or opt out or whatever, but that's kind of the point of the cookies. Advertising only to people likely to purchase the product. No, again, that's kind of the point, is, yeah, we want to advertise to people who are likely to purchase it. D, determining advertisements for a specific person based on information that was obtained through a posted privacy policy. I don't know how you obtain information through a privacy policy. I thought privacy policies were just posted and then you read them. I mean, I think they're trying to say, well, you know, if you agreed to your information being used in a certain way based on the privacy policy, which you probably didn't read anyway, then it's okay. So it's going to be A. Okay. Which of the following is a true statement about data transmitted over the internet? All data traveling over the internet is binary. True. Packets are received in the same order that they are sent. False. That's something that you really have to know. Packets, you know, your message, data, whatever, is split up into packets, and then it is sent out over the internet. The packets do not necessarily arrive in the same order that they're sent, but the TCP/IP protocol makes it possible to reassemble the packets in the correct order. So 2 is false. 3, internet is built on redundant connections. Yes, again, that's an important concept that was the original idea. So I think that, you know, gee, what if we have a nuclear war and you know, the connection from A to B gets knocked out. So, well, we could build a bunch of redundant connections, so even if some of them get knocked out, then the internet is still usable. So 3 is fine. Internet protocol is designed to be inexpensive to allow access to smaller websites. And that's just silly. So it would be 1 and 3. All right, so we've got some What am I trying to say? Flowchart symbols defined up at the top here. Ovals are start and end. Rectangle is a processing step. Diamond is a decision step. Parallelogram displays a message. What will the below algorithm display? And that is happening here. What it's going to display is num. So maybe it makes sense to keep track of what num is. So when we start out, num is 1. All right, and then we drop in here. Is num greater than 6? No. And then we drop into false. And that goes to num equals num plus 1. All right, so now num equals 2. Follow that around and we're back to is num greater than 6. All right, so I think I see what is going to happen here is we're going to have to go through that loop until num is greater than 6. So eventually num is going to get to 7 and then it becomes true. So true goes in over here. Num mod 2 equals 0. 7 mod 2 equals 0. That's false. So again, we drop out, we add 1 to num. Now it's 8. Go back around. Is num greater than 6? Yes. Is num mod 2 equal to 0? Yes, it's true. So then we go down here, display num. Okay, so it's going to display 8. So the answers here. Whoa, what happened? Oh, okay, there we go. Cable internet, ISPs, switching to 5G data networks from 4G data networks. 5G has higher bandwidth than 4G. What is the advantage of having higher bandwidth? It's faster. A, it would increase latency. No, it would decrease latency. Higher bandwidth would result in higher data transfer. Yes. It's about as far as we need to go with that, actually. All right. Yeah, that's the point. It's faster. The following program is intended to return the maximum number in a list called nums, which contains 100 numbers. The above program does not return the maximum number. Which change should be made to the program to make the program work as intended? All right, well, let's take a look. So we set max to the first number in the list. Okay, that's good. We set index to 1. That's good. Repeat 100 times. Compare each number to max, and if the number is greater than max, then put that num into max. That's good. The problem is the index is not being updated correctly. This line 8 shouldn't be inside the if. What's going to happen here? If num's index is greater than max, no, it's going to get like, once you hit something that's not greater than max, it's just going to be stuck there forever because the index is never going to get updated. So the index has to be outside the if statement. Let's see, swap 8 with line 9. Yeah, that would work. Yeah, no, that's it. You swap 8 with line 9. Which of the following is true about the Internet Protocol? IP addresses are hierarchical in nature. That is true. You need to know that. The Domain Name System, DNS, translates names to IP addresses. That's true, and you need to know that. You need to know what the DNS does. IP packets are received in the same order that they are sent. We've seen this question. They're not. You also need to know that. They are not necessarily received in the same order that they are sent. So far we've got 1 and 2 are true. 4, every object connected to the internet has a unique IP address associated with it. Yes, that's how, that's the only way to access it. So we got 1, 2, and 4. Okay. What's the benefit of program development using an iterative and incremental process? Okay, iterative and incremental. Well, iterative means, like a loop, like over and over, incremental. So what you're doing is you're adding a small increment of code to your program over and over and over. What would be the benefit of that? Eliminates the need for programming language to be converted to machine code. No, so you still need to do that. Decreases the need for documentation. Actually has nothing to do with documentation. Decreases the time needed to program an algorithmic solution. No. Helps programmers encapsulate where errors are located by adding code to a working error-free program. Yeah, that's actually an important concept. You can't just write a big program that works. You have to start by writing a small program that works, and then you add another feature and check and see if it still works, and then you add another feature, check and see if it still works. So, yeah, don't even just working on programs by yourself. Don't write 100 or 200 or 500 lines of code before you check and see if it still works. Write a very small amount of code and check and see if it still works. Because if it doesn't work, you don't have very many places to look. Otherwise, it's like, well, geez, it's somewhere in that 500 lines of code that I just put in. All right, so D is the answer to that. So that's an important concept. An API provides a procedure, max, which returns the greater of 2 integer arguments. Which of the following code segments it's confusing. Which of the following code segments will display the maximum of the 3 integer values x, y, and z? I got to think about this for a second. Okay, well, let's go ahead. I may need to check the explanation on this, but okay. So program B is like the canonical way of doing this, which is to display the max of x and the max of y and z. So max y and z will get the max of y and z, and then compare it to x. So you'll get the max of the 3. Some programming languages let you, will have a max method where you can put more than 2 integers in it. Some don't, but this we're assuming we'll just take 2 integers. So B is fine. C is not right at all. If x is greater than y or greater than z, then display x. But this is going to be true if x is greater than y, even though that doesn't say anything about whether x is greater than z. Not only that, after this display, you could display more things down here. So B is right and C is wrong. So actually we can eliminate B, C, and D and just go with A. But program A doesn't look right to me. All right, let me see the explanation. All right, feedback. Use the sample numbers. X is 11. Well, okay, so they give you sample numbers. It works with their sample numbers. Okay. We got the right answer because C is wrong. It's just about as wrong as you can get. So that allows us to eliminate 3 of the answers. But let's use different numbers here for x, y, and z, and see if program A actually works. So here's program A, and we're going to say x equals 11, y equals 11. What is the bottom one? If z is greater than x, okay, well, we'll make z equal 10. See, now if you go through this, you get, is x greater than y? No. Is y greater than x? No. Is z greater than x? No. So it doesn't display anything. I mean, there's a built-in assumption here that's not stated that, you know, x and y aren't going to be equal to each other. But in any case, program A is wrong, but, you know, fortunately it was set up in a way that allows us to get to the correct answer. Lisa's creating a procedure to determine the average of her computer science exams. This procedure takes as input a list containing all her grades for the school year called Score List. What will replace missing code so the procedure works as intended? And what we want is the average of all her exams. So how do we get the average? Add up all the numbers, divide by the number of scores. So we have total, we have count. For each item in Score List, add the score to total and increment count, and then the next step would be to return total divided by count, which is C. I was going to say C explanation. We don't need to see the explanation for that. A program wants to swap all the values contained in index 1 of all the values contained in index 1 of the list animals with index 4 in the list of animals. And there's the list. Which of the codes swaps the animal contained in index 1 with the animal contained in index 4? Okay. Usually if you want to swap the values of two variables, you need a temp variable. Some programming languages will let you do just a direct swap and use a temp variable behind the scenes. For the APCSP test, you're going to need a temp variable. So what does that mean? Means, first of all, let me scroll this up a little bit so we can see the things that we need to see. All right. All right, this doesn't work. You can't just say put 4 in 1 and put 1 in 4, because once you put 4 in 1, you don't know what 1 was anymore. So this, this is 4 over here. If we take that and put it into 1, and now we put 1 into 4, we're just putting, the rhino, which is now in 1, back into 4. You could think of it like this. You've got a glass of milk. You've got a glass of orange juice. You want to swap the contents of the cups. So you start by pouring milk into the orange juice. Okay, now what? That isn't going to work. You're going to need another cup. So here we got temp, and we put animals 4 in there. This still doesn't work because we're still going to wipe out 1. The idea is to put something in temp and then replace that variable, not to put 4 in temp and replace 1, but to do something like this, to put 4 in temp and then replace 4. And now you have the previous contents of 4 in temp, so you can put that into 1. So that'll work. That is the way to do it. Which of the following is not true about search engines? Mobile search is critical for local businesses. I would say that is true. Search engines can filter their results. For example, not showing street views of military bases. I would say that is definitely true. I mean, I've never heard that, but I assume that it's true. It wouldn't make sense for it not to be true. Let me put it that way. Search engines can filter out content that does not comply with the Digital Millennium Copyright Act. Yes. I think so. Let's read the next one. Search engines are required by law and enforced by something to present non-filtered results. No, that's wrong. That is wrong. I have to admit, I hadn't really given a lot of thought to B and C. Maybe that's something that's covered in the current curriculum, but this is so obviously right that, you know, if you could just pull up Google Maps on a military base and and see everything that's going on in there, you know, yeah, give me the street view on that. That's obviously wrong. So no, you're not required by law to present non-filtered results. Some programming languages use constants, which are variables that are initialized at the beginning of a program and never change, which the following is not a good use for a constant. Okay, so this is one of those questions where the first answer is so obviously correct that you don't really have to look through the rest of them. Time remaining in a football game is not constant. Which of the following can be stored using a single bit? Well, the only thing you can store in a single bit is a 0 or a 1, so it's Boolean. A temperature, no. A number in the millions, no. A byte, no. A byte is 8 bits. A Boolean value, yes. Which of the following characterizes a low-level programming language? Little or no abstraction from machine language. Yes, that's true. Yeah, we're talking about low-level programming languages are close to the native language of the computer processor. Very little programming is is done in what I would consider low-level programming languages anymore. But it used to be. I mean, it was not unusual. Even during my career, that people would use assembly language to do programming. Anything you use now, I mean, I don't know what's the closest thing to a low-level programming language, but not used that much. And then high-level programming languages are more human-like. So the rest of these are going to be wrong. Similarity to human language, no. Ease in coding, debugging, and maintenance, no. They're not easy to work with at all. Strong abstractions from the details of the computer, no. You're going to be programming like very closely connected to the actual hardware of the computer, you know. the registers and so on. So yeah, this is the answer. What will the following algorithm display? A is a string, B is a string, C is a string, and display A plus C plus B. All right, so that would be, I gave my love a cherry that had no stone. There's only one option here. I mean, this is not a great question because they have, gone to the trouble of putting spaces here in some places like this. I gave my love a space and then another space here, cherry, but then there's no space here after cherry and there's no space before that. So really cherry and that should be mashed together like one word. But since that isn't an option, then we go with B. What does the following algorithm display? We see the answers here. All right, so I guess spacing is not an issue on this one either. So we have three variables. They're initialized to certain values. If x is greater than y, which it is, or, and we don't have, it's already true. So display waffles. So it's going to start with waffles. So we've eliminated B. If x is greater than y and x is greater than z, that is not true. If z is greater than x and x is greater than y, that is true. Then display Benji. So it'll display waffles and Benji. Waffles, Benji. All right. Which internet protocol is used to break down objects into packets to be sent through routers in the internet? Okay, you should know this. TCP/IP. FTP, that's a file transfer protocol. IETF, it's kind of a task force. It's not an internet protocol. IC-ROM, I don't even know what that is. Integrated circuit, read-only memory. In any case, it's not right. TCP/IP. That is what the internet runs on. What is the minimum number of connections that need to be broken to completely isolate computer A from computer L? So A is over here on the far left. L is over here on the far right. I don't think the way that I would approach this is to start like breaking connections in the middle because there are so many. There are so many that, what are the possible answers here? 1, 2, 3, and 4. That I don't think that's going to be the best approach. Now, one approach is you can just knock computer L out of the network by breaking two connections between L and K and L and J. I don't see how you could do it with one. So I would go with 2. And again, you can knock A completely out of the network, but you would have to break 3 connections. So it looks like the answer here is going to be 2 as the minimum number. What describes the property of the internet that enables the system to continue operating properly in the event of the failure of some of its components? Centrally controlled. No, actually it's the opposite of centrally controlled. B and D don't really make much sense, but the answer is, exactly what it sounds like. It is fault tolerant. And it just doesn't just apply to the internet, but anything that's built in such a way that it can survive the failure of some of its components would be fault tolerant. Which of the following simulations will result in a Boolean variable that is only 2 possible results? 6-sided die? No. Coin flip? Yes. That's heads or tails. Is the pool opening today? Yes or no? the color of the plant that's looking at me. Well, there's more than two colors, so I'm going to go with what we have there. Select two answers. Why is the internet switching from IPv4 to IPv6? Okay, well, IPv6, and now I have to admit that I don't remember the details, but IPv6 will generate a lot more IP addresses than IPv4. You know, the standard IP addresses that you see, which is, you know, three digits followed by 3 digits followed by 3 digits followed by 3 digits. Why is the internet switching? Well, because there's more devices that need a globally unique IP address. Yes. TCP/IP? No, it's not going to change. Higher bandwidth? No, the IP addresses have nothing to do with bandwidth. 4 billion unique IP addresses will not be sufficient compared to the growth of the internet. Yeah, I think that's fair to say. So let's go with that. Okay. Let's see, what are the benefits of using abstractions in programming? Select two answers. Hiding or removing irrelevant data so that a program is easier to code and understand. Yes. Yeah, abstractions. It means, you know, well, I mean, what am I trying to say? Yeah, it means you hide or remove the details. You write code and somebody else may use it. Somebody might write code and you might use it, but you don't really have to know how it works. You don't need to know what's happening inside the program to be able to use it. This applies to a lot of things. You can type a message into your cell phone, hit send, and you don't really have to know how that text gets out of your phone and into the other person's phone. That's been abstracted away. So yeah, abstractions, keeping common features or attributes to various concrete procedures. Yeah, I mean, that's not a great description, but yeah, you want to keep features, you want to keep related features together, you want to keep related data together, as well as the operations that, you know, the methods that operate on that data, keep them together. So that also falls under the umbrella of abstractions. Increasing the level of complexity of code is not a good thing. Increasing creativity when collaborating, I don't see how it does that. So let's go with this. I'd actually be interested in seeing if they have a useful explanation for this. Abstractions reduce the level of complexity of a program. Yes. Okay. Constants, expressions, statements, procedures. Some of those I don't really think of as abstraction, but procedures definitely. Libraries definitely. More effectively apply available resources and tools to solve problems. Yes, you just need to know, like, what they do, not exactly how they work. Okay. Which of the following is a benefit of using open standards and protocols for internet communication? Open standards increase adoption. Yeah, if everybody's using the same standards, then it is yeah, it's I'm trying to explain something that seems obvious and make it sound complicated. But yeah, if everybody's using the same standards, it just makes it easier to, to work together. Increase in bandwidth. It actually has nothing to do with bandwidth. Decrease in the digital divide. No, it has nothing to do with that. No interpretations in communications are required between all types of hardware and all kinds of operating systems. Yes, that's true. It's not true of everything in computing, and it's one of the things that introduces a lot of difficulties that, different browsers handle things, different browsers will display your web page differently, but there are some open standards that work exactly the same on any kind of hardware, any kind of operating system. So that's good. Cost of concessions at a girls' lacrosse game is listed below. Which of the following algorithms will return the total price of the game time snack if what? If true. I don't know what that means, but okay. Select two answers. Oh, that one is sort of cute. Okay, so what do we have here? Hot dog $2, giant pretzel $1.50, fish sandwich $3. Okay, this is not a good way to program this, but I think it'll work. If you start out with price equals $6.50, which is the cost of everything here, $3 plus $2, $5, $6.50, and for everything you don't order, you deduct the price. That should work. Like, if you don't order anything, then we deduct the full $6.50 and you owe nothing. But for everything that you do buy, we leave the price in there. And so, yeah, that should work. We need something that's kind of like where the price starts at zero, like the reverse of that. Like the price starts at zero, and if you order a hot dog, we add $2. If you order a pretzel, we add $1.50. If you order a fish sandwich, we add $3. That looks like it'll work. No, see, this is wrong. If hot dog is false, add $2. No. No, this is wrong because it's not adding it to the price, it's just setting the price. So, yeah, what you would want to do is give me a hot dog, give me a fish sandwich, give me a giant pretzel, your total cost will wind up being $1.50. That's not correct, so let's see what we got here. That's right, and that is right. The question below uses a robot in a grid of squares. The robot is represented as an arrow, which is initially in the top left square of the grid and facing right, which of the algorithms below will get the robot from the starting position to the heart. All right, there's no way we're going to be able to see these answers and the grid at the same time, so let's just look down here. Repeat until heart reached. If can move forward equals true, then move forward, else rotate right. Looks like it would work. Move forward as long as you can move forward, and if you can't move forward, turn right. All right, so we move forward until we get here, and then we can't move forward. So we turn right and then we move forward as long as we can move forward, which is to here, and then we can't move forward, and so we turn right and we got the heart. Okay, so that one works. What is this one? What's the difference? If can move forward is true, move forward, else rotate left. No, that's not right. Another one, they're going to count it off. Okay. Repeat 6 times, move forward, rotate right. Move forward 6 times, rotate right, move forward. Is it 6 in each case? 1, 2, 3, 4, 5, 6. Turn right. 1, 2, 3, 4, 5, 6. Turn right, and there it is. Okay. Well, that one's right, so there's no need to look at the last one. Okay, that one's good. That one's good. 65 to 67 are based on the following. A web browser is selling its information cookies to third-party marketing companies. These companies are profiling users and selling this sorted data to targeted advertisers. I don't even understand all this stuff. Selling cookies. That doesn't even make sense. But I mean, I get what it means. They're selling your information. A browser is debating adding a setting called Do Not Track to their browser. Once enabled, it would send a Do Not Track signal to the websites you visit, informing them that you do not give them permission to collect or share your personal information for behavioral advertising, price discrimination, any other purpose. This setting would stop data brokers from legally selling your personal information from the sites you visit. Again, does that really make sense? I see. Oh, okay. So from the sites I've okay. I think I got it. Which of the following is the most likely data privacy concern for the original browser? Now, see, I don't know what that means. The original browser, who is the original browser? Is that me, or is that the company making the web browser? Because the way they phrase it over here is a web browser is selling its information. So it's like, what's the concern? I don't know. So let's take a look. Information collected, your personal preferences might be used to brand you as members of a particular group. That is an APCSP type of answer. So let's hold on to that. Cookies are used to acquire users' private encryption keys. No, encryption keys don't go in cookies. Cookies are text files that keep track of they are, but that's not a privacy concern. Cookies are responsible for spam and create pop-up advertisements. No, you can have spam and pop-up without cookies. So really we want to go A. Yeah, let's go A. Okay. All right, so same question. Which of the following groups is least likely to receive targeted advertisements? Well, it would be the people that say do not track. Yeah, this one, the browser with the do not track. Okay. And finally, which of the following potential benefits is most likely to be provided by the upgraded system? Weather websites, customizing site information. No, because the upgraded system means that you have said, I don't want you to track my information. So that means, like, I don't want you to track where I am, things like that. Increased speed in ordering pizza online. The web page remembers address and credit card. No, again, you said do not track, so that's not the case. Limit the information that is available about sites and stores. The stores. I guess that means online stores. The user visits. That looks like the right answer. offer products and services that are more relevant to the user. No, I mean, I guess that's the trade-off. You can share information, and I mean, if you don't share information, you're still going to get pop-ups and ads and things like that. They just may be less relevant. But I don't know. It's up to you. But limit the information. Yeah, if you're concerned about limiting the information about you that is available, then that would be the payoff. All right. An e-commerce site wants to increase internet sales from visitors who created an account, put an item in their shopping cart, but exited the page before completing their order. The site's new system is going to send targeted follow-up emails 48 hours post-cart abandonment, along with similar product suggestions to all customers who do not complete their purchase the first time. Which of the following input data is needed by the upgraded system that wasn't needed by the original system? Cookies to store items in the cart, login, name, pages viewed, time of visit. Yeah, you would need all that. I mean, it doesn't necessarily have to be in cookies, but I mean, I get the point. User age, irrelevant. Type of sites the user frequents, no, you're not going to get that. User's gender, no, that's not important. No, what you would need their cart, obviously, and the time of visit, so you could identify 48-year-old or 48-hour-old shopping carts. You would need to be able to identify the user and pages viewed, meaning you could say, hey, are you sure you don't want this? We noticed you looked at this. So, okay, A. All right. Last question. Oh, it's the same thing. Which of the following data is not provided directly from the user, but is needed for the upgraded system to operate as described? Yeah, I mean, when you put it that way, the thing about like what pages did the user visit, in the first answer is not all that relevant because I'm reading it again here. It's like similar product suggestions to what's in the cart, but not to other pages that you visited. So, and do you need an address where to ship? No. Do you need a list of products so that the site can categorize similar items to be suggested for purchase? Yes. See that here, similar product suggestions. So yeah, we need that. Credit card, no. If it's a gift, no. All right, good. Submit. What happens when we submit? It'll be scored. Okay, go ahead and score it. 100%. Oh my goodness. All right. Well, that's it. That's APCSP. And as always, please feel free to subscribe to wherever you're watching this. You'll get notifications when new content is available, which should be frequently. And I'll see you next time.